Hey guys, how's it going? So this is the next episode in the Coding Minecraft streams, and we basically got lighting working for the most part. I might have broken something because I was adding light sources really quickly, so we'll have to check that again, but mostly working. Yep. And how's it going, CGO Clan, Langors, Eddie Dev, Voxel Riffs? Good to see y'all. Voxel Riffs, we will be going over your code at the end of today's stream. So once, probably like 10 o'clock ish, I'll start going through that just so that we can check it out. But CGO Clan, I messaged you in Discord about that. So the only reason I'm not going to be accepting the PR is just because if you want to submit a PR, I would suggest it would actually be the bug fix, not just like the updating the README. So on GitHub, we've got the issues tab. So you can just submit the bug requests here, which is a much better place to track and close issues and stuff. So that would work best. Yeah. And no reason for Pepe Sweat Voxel Riffs. Hopefully it'll go very well, right? It'll be fun to look at, and I think it'll be cool to just sort of explore that. So yeah. Okay. Hopefully it works. Famous last words, right? I know that all too well. But let's see what I've got now. It's kind of broken right now, like I said. I realized that just a little bit ago because I changed some stuff very last minute. But basically, you can see it still generates pretty quickly too, which is good. One of the things that we had noticed before is like in long tunnels like this, it would not generate correctly when we first entered in. But now you can see that we have this. And if I go ahead and I block it off, we get dark. And if I close, dang it. See, this is what I was saying. So I changed some things very last minute. Let's see. I changed this thing. I'm trying to think of what I probably shouldnly have changed. I think this should be this. And I think that's what I've changed. That's broken that. So let's try this again real quickly because probably best to fix this. And then I'll have to fix it for real so that it's getting the appropriate values. But basically, it's because I was trying to add light sources. So I got like the lighting actually working. And I was like, oh, now I want light sources. But, you know, that doesn't work very well, too. Cloning the repo every stream is hard. Yes, I bet it is. You don't have to clone it. You can just initialize it on your computer and then just pull the changes. And it'll be a lot faster. But, yeah. So if we do this, it breaks lighting. Okay, yeah, it's still broken. Huh. What did I change here? Let's go through the changes real quickly because I'm trying to figure out what I changed that broke that. So, yeah, I added this thing is light source to determine whether a block's a light source or not. And I added glowstone. So we should be able to add blocks that are, you know, that have that. And then what else did I change? Okay, so then I changed all this stuff, which should be fine. I don't think this is a problem because I remember checking it and it was still working okay. Okay, let's see. So then we did this. I think this could possibly... Wait, no, that shouldn't affect it when we're placing blocks. Never mind. Okay. So that's all good. And then we've got that. As you can see, the title is different because we're supposed to be doing Cubemaps and world generation today. But first I gotta fix this. So yeah. And how's it going, Essie Woods? Good to see you. Okay. So there's got to be something in here that I changed that must have broken this. Okay, so I've got this. Block data does not equal air block. Okay, this is a potential source that's broken. I don't think so, though. This is what I think it would be. Yeah, so this used to be equals 0, and then I changed it to this. Oh, and then maybe this thing? So I used to not have this. I say if it was a light source, we set its light level to the old light level. I don't think that should matter though. Oh, what did I used to do? I used to just do, okay, this is for removing blocks. So removing blocks, yeah, removing blocks is what's broken. Setting blocks was fine. Removing blocks is broken. So that's probably what I did. Yeah, so I have this old light level thing. Let's do this. And I think this should fix it. Okay, so if we just do that, this should fix whatever I had wrong with it. Basically, I was trying to set the light level according to some different things to get the lights to work properly when you break them. And I must have broken the real lighting when I did that. So, okay, so this is like this. And then if we go in here and we place 2 blocks, it gets dark. And it's still not getting light again. If I update it though, no, it's still not. If I update this, okay, then it gets really weird. Yeah, what did I do? I must have broken something pretty bad here. Because it was, I promise, it was working before this. Let's see. Okay, so I removed that stuff. I added that. That should all be fine too. And then I just set that to 0 when we're doing that. Did I turn that to, yes, so that's just setting it to 0. Hey Dev, do I use persistent map buffers? I do. Using that for the chunk memory, but I'm not using that for like other draw calls. I'm eventually gonna switch my whole rendering paradigm to all use that type of stuff, but for now it's just for the chunks. Okay, let's see. So I changed that. This could potentially be bad, but I don't think it's that. I think if anything, it's gonna be one of the ones in a different area. Yeah, like this thing. So this used to be false, but then I changed it to true. I think that could be the problem. Okay, let's do this. So let's go back up there. That was inside of recalculate, or maybe just calculate lighting update. Yeah, okay. So that's where that was. And I think if I just change this back to false, we should be good. Fingers crossed. And then I can show you what, yeah. Revert to old commit and start from there maybe, if it isn't a big deal. Yeah, I know. I just don't like doing that. And I want to see what the change was that broke it so that I can hopefully just keep the rest of the changes, because I'm pretty sure most of them were fine. And then that way we can go back and fix the one part that was broken. Okay, so if I do that now and then I place 2 blocks, we're good. Nope, still not working. Huh. Okay, what's the other changes I made? Because it could be something else. I'm guessing it could potentially be that as well. Maybe it was in the previous change too, because I should look at what changes I made. I'll revert in a minute if it's still really not going to work. Okay, yeah, so this is the one thing that I started changing where it broke stuff, I think. Let's revert real quick and see what happens. So if I go back to that previous guy, let's go ahead and we'll say stash our changes, revert, actually. So let's get this. Okay, and then we'll go, yeah, and then we'll revert to that one. Could not revert except for one small case after resolving the conflicts. Okay, so I have merged conflicts for some reason. I thought okay. Maybe I have changes I didn't push. I thought I stashed those changes. Let's just do a git add real quick. And then stash. And then we'll do that. No. Okay, what's happened? What's wrong now? Why is it still saying those are modified? I thought stash would like stash that stuff so that you don't actually have to use it. Do you have to commit it too? No, I don't think you do. Maybe. Wait. Voxrush, revert. Wait, not that one. You changed the wrong one. Rip. Too late, rip. No, I don't think I changed to the wrong one. This is the one that we want to be going to, because this is the one that I added that. This is the one that we're looking at here. For this commit, unless you're talking about something else. Yeah, this is the get light sources mostly working commit. So, I think I'm going to revert to this one. Oh, I changed the wrong true. Oh, okay. Thank you. Thank you. Okay, I see that now. Yeah, it's already committed it though. Okay, cool. But I think we still have Let's do git stash pop. And it's going to say it needs a merge. I think Visual Studio has like a merge conflict resolver thingy, but we're just going to do this. Okay, so yeah, and then it's got all of this stuff. Which one do I want? Crap. Okay, now I don't know where I should go. Can I just like abandon all changes and then go back to whatever it was before? This is why I don't like it. Wait, okay, there we go. So we got that, we got that. Okay, so I changed the wrong, oh, you're right. Okay, so I see now. So this should be false. And this was true before? This was true before. Okay, thank you, VoxelRiffs, for catching that. Okay, I think we should be good now, yeah. Okay, that is great that it was just that, but I just have to undo those changes too. Okay, yeah, thank you for catching that. Probably should have seen that. See, I spent 16 minutes on this already. Man, I gotta figure this stuff out sooner and not do this. I guess it was only 10 minutes really, because I had 5 minutes of that waiting screen, but yeah. Okay, let's see if that fixes it though, because I think you're right. I think that is the one change that I did that broke things. So if we do this, sweet. Okay, yeah. Okay, so lighting's working, right? So I fixed it for the most part. I added in block lights too, and that's what that whole debacle was with that stuff. I even fixed the part too where it's like if you have a chunk that's on a chunk border, it corrects the lighting the first try. So like the light gets set correctly the first time. We're going to commit these changes too, so I don't lose these. The only thing I don't have working is something like this. So if I break this, you'll notice this chunk face is still black. Why is it still black? Because this is a chunk border. So what happens is I update this chunk and then we start flood filling. And then basically what happens is we get to this point and then we say retessellate this chunk that I'm standing in. But since we never actually touch any of these blocks, we don't retessellate this chunk. And so they all have their old light values. So basically what I need to do is add in a function that basically, or like some sort of method that says, hey, if you touch any chunks, like if I get onto a border, make sure to retessellate that chunk as well. So I don't want to deal with that right now. We're going to deal with it later. It works, and that's all that matters. CGO clan, wait, now how should I clone it again to follow you? Well, I'm not going to be pushing, well, actually I am going to push these changes real quickly. But for the most part, I usually don't push the changes I make in the middle of a stream till like the end of the stream. Revert bad changes. Yeah, so you should be able to pull now. But usually I'm probably not going to push until the end of the stream and stuff, or until I get to a point where I think it's a good place to push something. Yeah. Voxers, instead of updating just one chunk, maybe you should update all the neighboring chunks or something. See, that's the easy way, and I like that, but I can't, there's a part of me that's like, I can't do it the wrong way. Like, I just have to update only the proper chunks, because it actually does take quite a bit of time, and if I can avoid wasting unnecessary time on updating stuff I don't need to, then I can. And it's not such a major change that it's like gonna be too hard to add. It's just, it's more annoying than anything, because like, it works, I just have to fix that. So, yeah. If you change anything, you might have to solve conflicts. Yes, or you could stash them like I tried to do, and then you should be fine, normally. But yeah, okay, so lighting's working. Woo, finally. I can't believe it. After the whole week, which was, yeah. Let's also mark that off in our README real quickly. So, yeah, we got this part done. It's sort of done. The light sources were sort of working. I can show what's happening in those cases and stuff. It's like mostly working, but then because of those changes that I was trying to make, we just have a couple of issues. So like if I go into here and then we'll put a stone block over here. Yeah, okay. So if I go to 9, I think this is, or 8, this is glowstone. Yeah, and so you can see it lights up the room, which is good. Like that's what's supposed to happen. But if I break it, we get sort of the same problem that we were getting when we would do this. And I know exactly what the problem is. I had it fixed, but I need to like add some special case code for breaking light sources versus breaking like a normal block. And that should fix everything. And then we should be good. So yeah, light sources were pretty easy to add once we got everything working. And then you'll also see if I update this chunk, it fixes it. But we just got to fix the rest of that and we should be good. But later, I want to do Cubemaps and I want to actually start doing world generation. Another thing that's not quite good is if I add a transparent block. I think one of these are leaves. Yeah. So if I had a transparent block, you can see through, but the light's not actually getting through and it's dark on the sides. And that's something else that I need to add support for. But that's something that comes later because it works good enough right now. And there's no major problems with like the algorithm itself. It's just those edge cases I have to fix. So yeah, on to Cubemaps, which is something that I've been meaning to do for a very long time. SE Woods. To put code onto GitHub like you do, will GitHub walk you through how to when setting it up? And very noob to cloning. Oh, you're very noob to cloning repositories. Yeah, it kind of does for your first repository. And I would say just use like the very basic things, which is like commit and push and pull. Don't try to do anything too fancy when you're first starting because GitHub is very annoying. Like Git, I guess, not GitHub. It's very annoying. But yeah. And yeah, lighting is basically done for all practical intents and purposes. It just, yeah. And then the way you add light sources too is pretty neat. Like if you want to add a block that has a light source, you just set it to be a light source and then you set the light level. So for instance, that glowstone was pretty not light. So if we set it to 31, which is the maximum value, and then we go back into here, you'll notice it'll be the same as sunlight. So if we go back into there. And there's also issues when multiple lights get put next to each other that I have to fix. So that's annoying. I'll show that real quickly too, just so that we can see it. So if we go in here and then we place down one glowstone, now this is much brighter just because of what I did. But then if I like put in another block over here and I start breaking them, even if I had it like the breaking code working properly, it doesn't quite do the right thing. So that's some other stuff that I'll have to fix at some point. But yeah. Okay. At the moment, I just use external hard disk. We'll look into GitHub at some point. Yeah, GitHub is really nice, just in case you do mess things up. So it's always good to have that backup. And then you can also see your changes and stuff too, like this, which is nice, just so that you know what's going on. Okay, anyways though, whoops, that's not what I meant to do. Let's go ahead and start work on Cubemaps. So we will go back to here. I think I have Cubemaps up here somewhere. AMDev83, thank you for following. Good to see you. The 2 memory leak logs are still there, by the way. Yeah, that's just because of static objects. So if you'll notice, like if we run that again, and we stop, once the threads all stop working, yeah, there we go. You'll see this comes from pool.hpp line 22. So what's happening there is I have a couple of pools inside of the chunk manager. I think it's a block pool. Yeah. This is static lifetime, and so it doesn't get cleaned up till after the application exits, but it's not actually leaking because this has a destructor, which does clean up the memory. It's just that it gets cleaned up at the end of the application lifetime, and I'm printing memory leaks inside a main. So, not this main. Yeah, this main. So I dump all the memory leaks before I actually exit the applications thing. So yeah, the static lifetime and everything just sort of messes with that. So not true memory leaks, but they're there. So yeah. Many people are talking about GitLab. What's the difference? I have no idea. I haven't actually seen GitLab, so or used it. Okay, so let's go. I don't need this. Also, CGO clan, I noticed that one of your bugs you said E's, like the letter E, doesn't line up properly. And that looks like it's lining up properly to me. I'm not sure if maybe it was something else that you were referring to. So, yeah, because I'm pretty sure I have all the font stuff like ironed out. Yeah, that all looks like it's lining up properly to me. So yeah, sorry, I meant the height of the letters. The height of the letters I think are good too. Yeah, that all looks good to me. It's a bit incorrect for S. That's not, that's just an issue with the font. Yeah, so I think that's how it should be. It's just how the font was designed. But yeah. Yeah, because you'll notice like D and B have different heights for their circles and stuff too. But yeah, so that should be fine. Okay, Langor's SE Woods. Git is much better than using hard disk. Yeah, because you can reverse them and you also don't lose them since it's stored. What font am I using? I'm using some font I found on DaFont, which is just free fonts. I can't remember what it was, but I think it's called Minecraft. So, whoops. Okay, so let's go look at Cubemaps though real quickly. I already sort of took a look at the articles for this and stuff. I'm wondering how much of this I should save. I'm going to bookmark this just in case I have to come back to that at some point. We got that open. Yeah, this was some other stuff. Okay, let's just open this up for now. So I already know sort of what goes into the Cubemaps and stuff. But we're just going to go through it and then do this. So the basic idea with a cube map is, yeah, you have like 6 different textures, one for the top, bottom, right, front, back, left of a cube. And then what you can end up doing with it is creating skyboxes and stuff, right? So we've got all this stuff. So it shouldn't be that difficult to implement. Famous last words. So let's just go into Minecraft and we're going to go into here. And inside the render, I'm just going to add like a cubemap.h. And we'll just do this the simplest way possible, which is we will take 6 different textures. And these textures will be the top, bottom, right, front, whatever. And then we'll go from there. So hash if not defined Minecraft cubemap.h. We will define that and we'll do namespace Minecraft namespace cubemap. We might not make that a namespace. I don't know. It might work better as like a structure because you could have multiple. Yeah, I think we're gonna keep this as a structure. So we'll have a structure cubemap, which takes in like texture pointers, 1 for each side, and we'll do all that stuff. Yeah. Voxeros, major difference is using 3D vector for sampling. Yeah, right. I've never used Cubemaps before. That's what I think. So like you could see from this, you basically just sample by shooting array, sort of. Not quite shooting array, but that's the basic idea, into the side of the texture to figure out what color the sky should be and stuff. So yeah, we'll see. Should be pretty easy, but we need 6 textures. So if I do I want to make sure I'm doing the same sort of format for all my different rendering stuff. So let's take a look at font to see how I store textures in there, which I think is just a pointer. So if we look at font.h. No, we just stored the raw texture, which a texture is all this stuff. Yes, okay. So I'm fine with that. This might be kind of not good to be copying around, but you shouldn't be copying this stuff around too often. So yeah, we'll just use a texture then. Lingors, you're right. Just haven't bothered taking the time to set up the basics. Yeah. So it is nice to have Git and stuff just in case. And it is also annoying to learn. So I can see why you would put it off. I mean, I would have put it off too for quite a while. Okay, so we'll have texture, 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 and texture, and texture. And I would do this in like a union with an array of textures, but that's not going to work because we have a file system path in here. So that would break things. Everything else is fine except for that. Okay, so we've got that. Let's go ahead and go into render over here and we'll create a cubemap.cpp. And then we'll just include that. Okay. So let's go from there. It's not showing .h for me, it's showing .cpp. Yeah, not sure what you're talking about there. Okay, so if we take a look, he says Cubemaps texture is like any other texture. So to create one, we generate a texture and bind it to the proper texture target before we do any further operations. This time binding it to GL texture map. Okay, so let me go into my texture class because I might have to change some stuff in here. Okay, yeah, so we do have set texture type, and then I'm just going to go into here. We'll add a cube map. Okay, then I can go into here, and we'll say there's probably something in here. Yeah, so we'll do this. That's the wrong one. Okay, I should have something in here that converts a type to a GL type. Somewhere in here. Ah, here we go. Okay, cool. So then I'll do a case texture type cube map, and then we'll do, oh, and this is something different too. This is for generating textures. Ooh. So I should probably have something that just gets this, but we might have to do a different kind of text for this. Let's see. So he basically says we have to loop through all the different textures, load them, and then we do a GL text image 2D. Okay, cool. Oh, but then we have to choose the appropriate cube map thing and all that stuff. Okay. So this is going to be a little bit different than what I usually do for my textures. This is annoying already, but it's all good. Langors is pinging himself and writing. Okay. So, I'm used to doing this for just textures that contain one texture, because that's what a texture is, but a cube map is 6 textures, so I'm thinking of what the best way to do this would be. Because when we do the GL text image 2D, what we want to do is one of these guys. Yeah, so I think the easiest thing to do would just be like literally to just add cube map with just like OpenGL does, positive X, and then this will equal 1, 2, 3, and then we'll do it the same order that OpenGL does it. That way we can just add stuff. So OpenGL cube map. Nope, that's not what I wanted. I wanted this. There we go, cube map texture. So this is the order. They have positive X, positive Y, positive Z, negative Z. So we'll do the same thing, positive X, negative X, and we'll copy that. And then we'll just do the same thing here for Ys, and same thing for Zs. Okay. And then we'll just do 4, 5, 6, 7, 8. Okay, and then if it's any of those, cube map negative X. This is going to be positive X. If I can type, there we go. And then we'll do the same thing for Ys and same thing for Zs. Okay, so we'll have all that. And then if we have any of these, we can just say GL text image 2D, GL cube map positive X plus, and then we'll just do the textures type this, cast to an int minus texture type positive x. Okay, cool. So that should be the type. Let's actually just put that into an integer too. Text type equals that. Okay. And then we can just use text type. And then we need the level. We'll just do 0 for now. Internal format, which I sort of get set up all automatically. Width will be just the width of the texture. The height of the texture. The border, which it looks like I'm setting that to 0. That, and that. Okay, cool. So that should do everything we want. I might have to add this in one more place though, which it looks like. Let's see, what am I doing here? I just have to make sure I'm not doing something weird. Okay, so this is for the type. Yeah, so for the type, I also have to make sure that this is correct. I really should just have, let's just do this. This is gonna be the simplest way. So we'll do a void. I think I have this somewhere else too. Let's do uint32 2gl type, and then we'll do a texture type. Okay, so that should be good for converting textures. And then we'll do that, and then we can just do what we basically did in here. With that, okay. So that's the type. And then for all this, we'll just return that. This will return that. I think this is the definition of overcomplicating things. We'll return that. And then for default, which will fall through anyways, we'll just say G logger warning unknown texture type. And then we'll return none. Okay, cool. So this is just that. Okay, I think that's all we want to do. Let's just do that. Remove those. Cool. So then when we go here, we can just say uint32 texture type equals 2gl data type, or I guess it's just 2gl type, I think is what I called it. Yeah. And then we'll do texture.type. And then we can just use that here. Cool. So with all that good now, we can go back down to where I saw this, change this to, instead of doing this, we'll say texture util 2gl data type texture.type. Okay, cool. Oh, I just have to make this const. Oh, no, I don't. That's taken by a value. What's this? 2gl type. Okay, cool. Let's just make sure I didn't break anything very quickly, and then we'll keep going. Half a heart. Good to see you. C++ is a bit of a little name C with extra stuff. Yeah, basically. Shouldn't that be GL texture cube map positive Z? I will double check because I might have messed that up. Yes. Okay, C# and C. Okay, looks like you guys are getting into some language discussions. Looks like everything's working right. I just want to make sure. Yep, looks like everything is still working all right. So I'll just close that out and then make sure I did not mess this up. So we got positive, negative, positive, negative, positive, negative, X, Y, Z. And then did I mess something up in here? Positive, negative, positive, negative, positive, negative, X, Y, Z, positive, X, X. I think this is all right. Positive X is the first one here. And it looks like they are using positive X here as well. So I think this is all fine. Unless you were mentioning something else, Langors. So I'll wait on you for that. But yeah, cool. So we're good. Looks like that should give us textures. So now I don't have to do this stuff because I can just sort of use my own built-in texture thing to load all the data and everything. Yeah, and it looks like this is just doing a normal GL text image. So we basically just load 6 different textures. And you bind them all though. Okay, so this is where it differs a little bit. When we create it, we bind it to one cube map. Is what it looks like he's doing here. And then we just use Cubemap here for all the texture parameters. Okay, let's see if he goes into more detail down here. Okay, yeah, so this is like sort of the function info. So we basically generate one texture ID, which is just the Cubemap. Then we load 6 different textures. And then we do a text parameter I. So we text all of that data. Am I doing anything weird when I text that data? So when I do this, yeah. So when I generate an empty texture, it looks like I'm just texting that. But I think there's one other place where I do this too. Yeah, this is right here. So when I generate it from a file, I also want to say uint32 texture type equals texture util. To GL type texture.type, and then we also want to use that here, and we'll use a texture type this, and then we'll do basically the same thing. Yeah, almost. I mean, this is exactly the same thing. So I guess we don't even really need to do this. We could just put that up there. Yeah, and I think that should be fine. So then we just do that. This will be positive, and then we'll do Y's and then Z's. Y's and Z's. Cool. So that should load it, and I don't, okay, yeah, see, so I do generate a texture object when I do this. This is where it's not so good. So I might want to separate this functionality out. I'm trying to think of what the best way to do this would be. Let's see. I'm also going to put in just a regular cube map here, just that we can do like one cube map thing. I think the easiest thing to do would just be to separate this into 2 stages. And then when we text the image, we'll just text it based on whatever's currently bound. Okay, I think that's what I'm going to do. So where does that get called to? I just have to make sure. So yeah, this gets called right here when we generate it. So we'll add one more thing. We'll add a builder generate texture ID or texture object. And then we'll add a set texture object. Okay, yeah. And then we'll add a bind texture object. So this will make creating my textures a little bit more difficult, sort of. It's not gonna make them more difficult really. Just a little bit more verbose. Okay, so I have texture builder in here somewhere. Okay, this is where I've got it. So what we'll do is we'll do that. And then we'll do this. Okay, so get rid of that. For this one, what we'll do, and I guess for setting a texture object, we need to basically pass in texture object ID. Okay, that's all good. And then what we need to do is we need to, where do I have that? It's right down here. Yeah, okay. So we need to just basically move this stuff. So GL gen textures and GL bind texture. So we'll go up to here. This will do this. And then it'll set, I think we have a texture. Yeah, it will set the texture's ID. Okay, cool. So this just uses the texture's graphics ID. Cool. So this will basically generate that texture, bind it. We just need to make sure this binds the appropriate thing. Get texture object type, maybe do something like that. I don't know. For now, it can just stay GL texture 2D because when I set it, I'm going to be using something else possibly. I think about this. I'm going to check the chat really quickly too. Essie Woods, I'm very comfortable with Java at the moment. I intend to start with C++ anytime soon, but I might look at Gabe C++ series at some point. That approach would definitely give a student a solid understanding languages, although the transition from C++ to C#. Oh, you guys are still talking about languages. Okay, cool. So we've got this whole set texture object thing. This will just do like set texture graphics ID to that. And then when we do this, we'll just do GL bind texture. And we'll basically do the appropriate one. Okay, so this is what we want to do. And we just need to figure out which type it is. So we'll just do a uint32. I guess we could just do this. Texture util to GL type, and then we'll just give it the type. Okay, cool. And then let's add in support for just the regular Cubemap. So we'll say case texture type Cubemap return GL Cubemap. GL Cubemap texture Cubemap. Okay, cool. That should be good, right? Yeah, okay. I don't know what's up with this. It's probably just Visual Studio being slow. Because this all looks correct. Okay, cool. So I'm happy with that. And then if we go back to here, what happens is we basically say, okay, we can generate texture objects and then we can bind them. And we can also set the texture object. So we can set a specific one before we go and bind it and everything. I think this will probably be the best way to do this stuff. Does it matter what we have bound when? Yeah, okay. So we just need to make sure we have the correct thing bound when we go and generate all the texture objects. And then we're just separating this. So let me go find where I use texture builder. Just so that I can fix all that stuff. Okay, we don't care about that. We do care about this. Okay, yeah. So then here I just need to say dot generate texture object dot bind texture object. Okay, and that should be good. And then I have to do the same thing here. Dot generate texture object dot bind texture object. Okay. And that's all fine too. And then I have to do the same thing here. Dot generate texture object. Okay, cool. And then that should be fine. And then the generate function is what basically sets all this stuff up. So I shouldn't have broken anything, and hopefully we should be good. It would be cool if they allowed us to trade channel points for money. That's great. Is implementing Cubemaps hard? I don't, if you're doing it my way, probably harder than it should be, but it doesn't look like it's gonna be too hard. Yeah, it doesn't like this for some reason. What the heck? Oh, do I just have them all set to the same? Oh, yeah, I do. This needs to be like 4, 5, 6. I guess I could just let these take in their like normal values and we should be fine. Okay, cool. So those should all just be in increasing order, hopefully. I think that's the way C++ works. Okay, so now if we go ahead and run that, we shouldn't have any errors. And then what I want to do is we can continue working with like actual Cubemaps, because now we have a way to generate the textures and bind them and all that good stuff. So yeah. Okay, it looks like I'm forgetting to return this. Okay, sorry about that. Okay, let's go back, and I think we should be good now. There we go. Cool. And all of our textures are still working, so that means I didn't break anything. That's all good. Yeah, okay. So we can now generate that stuff. So now what we want to do is basically when we load a cube map, we want to, so he just takes in, man, and he's taking that in just straight up. There's no reference here. Okay, but anyways, what we need to do is go ahead. What are cube maps exactly, by the way? They're just like what you use for skyboxes and stuff. We need to go into here. I'll just add a static method in here because this is kind of what I like doing now. It's a little bit easier. So we'll have a cube map generate cube map. And we need 6 faces, which are like top, bottom, left, right. We could just take in like an initializer list of strings or file paths or whatever we wanted to. And that'll be a const reference. And then this will just be our cube faces. But then you have to remember like which one is top, bottom, left, right, front, back. Like you have to remember the order. I don't really like that. So I think what we're gonna do is just like const string ref top, bottom, left, right. Yeah, we're just gonna do this. Okay, front and then back. I prefer doing this. It's a giant function call now, right? But I prefer doing this just because with it done this way, you know exactly what parameters you're passing. Whereas with an initializer list, you have to remember the order that you should be passing it in, and that's just not cool. So we'll do this. Okay, and that's all fine with me. I just have to remove that static qualifier. Okay, so we'll just do that. Cool, that's all good. So then what we can do is we can generate one texture. So let's say cube map texture equals, we'll just generate like an empty texture. I don't even know how that works, right? So we basically, with my texture object thing so far, I think the easiest way is just for me to use the bare OpenGL calls like they're doing here. Yeah, and then I'll fix this up later so that it works properly. So we need to add one more thing in here. This could be uint32 cube map ID. Just that I'm keeping convention. And then what we'll do is we'll say cube map res, and then we'll do res dot that. And I guess we don't need to specify that's a cube map because it's already kind of implied since this is a cube map structure. So I'll do that. Okay, and then we'll just do bind the res.graphicsID. So then what we can do is we can just generate, or we can text all this image data, and we don't really even need to do like anything too special. And I guess we'll just do this too, because it looks like you don't do this per image, you just do this on the cube map as a whole. Okay. So then we'll just do like, trying to think the best way to do this. Res.top equals texture builder dot I think I can just do generate from path, and then we'll just do, whoops, dot set file path to top dot c string. Okay, and I think that's all we gotta do for each of the faces. So then we'll do bottom, left, right, front, and back. Okay, let me just make sure that this will work properly. So we do generate, that's gonna do this. Okay, and then when it does this, it's gonna load the file path, that's all good. Figure out what format it is. Then it's gonna bind texture parameters, which are all none, so it shouldn't do any of this stuff, which is good. I'm not sure if setting a swizzle mask, that's not gonna matter, yeah. So this is just for some other stuff that I had done before, but that shouldn't change anything. Okay, and then it's just gonna bind the appropriate texture, then free the pixels. Cool, so that should be fine. So we generate all of our textures, top, bottom, left, right, front, back, which is what he's doing here. And then we just set our Cubemaps texture stuff. So then we do this stuff, our parameters. So yeah, I guess we'll keep it linear. He says to do clamp to edge because it's kind of important when it comes to Cubemaps, and you have to use the wrap R parameter because we have a 3-dimensional texture, but yeah. It's basically a cube made of textures that you can use index into using a vector, because that it's usually used as a skybox by making cubes always centered around the player. Oh, have I fixed the oil on the car? Sorry, I just saw that, SE Woods. I did. I got my oil changed yesterday. But yeah, so we're all good there. That was just like something that I just had to do, and was waiting till this week when I had some extra time to do that. Okay, cool. So this should set everything up, I think. So now we've got a cube map. Okay, and then we just need to return that result. So then we just return res, which will now have these textures all set properly, and it will have this set properly. Cool. So then, when we display it, this is where it's going to be a little bit different. Because the skybox is drawn a cube, we'll need another VAO, VBO, and a fresh set of vertices like any other 3D object. So we probably need a custom shader for this too. I'm not sure how you typically go about drawing this type of stuff. Like maybe you just do a first render pass, which is just your cube map, and then you do the rest of your render passes, which is everything else. Is what I'm guessing you probably do. It's what I'm probably going to do here, and then we can change it in the future if I ever need to. So let's just go ahead and create those shaders really quickly though. Okay, so we got this. Let's do a new file, cubemap.glsl, and I need to capitalize that default just so that I follow the same naming conventions. I'll copy that for now, and then we'll just modify it. Okay, so let's just copy his stuff here, because this isn't anything too special. Oh, and I also have the versions wrong in this. This should be version 4 something 0 now instead of 330. Yeah. Okay, and he's not even including that too. Version, I think it should be like 460. I'll keep it this for now, just because of that, and I did that wrong. No, I did that right. Okay, cool. So we'll do that, and then he also does, oh, and I just forgot to copy it. And then we'll do this as well. Okay. So this just takes in a position. Okay, yeah, so this just takes in the position of the cube or whatever, I guess. And then it takes in a view matrix, so your projection of your view. I'm just gonna change this to be more my style. So we'll do that. We'll do that. And then we just pass through texture coordinates, and we have a skybox. that we bind, and we should be good. Cool. So let's try this. Let's see. Does he talk about anything else? Okay, when rendering the skybox is easy now, we have a cubemap texture. We simply bind the cubemap texture in the skybox. Sampler is automatically filled with the skybox cubemap. To draw the skybox, we're going to draw it as the first object in the scene and disable depth rendering. Yeah, so he does a first render pass and then all that other stuff. This way, the skybox will always be drawn at the background of all the other objects, since the unit cube is most likely smaller than the rest of the scene. Okay, cool. So he does this, he basically uses it, and then he binds it to VAO, which I'm assuming is, yep, just a cube, which we know very well how to draw a cube. And then we just bind the texture. Yeah, okay, that looks pretty simple. So let's go ahead and do it. We need another shader and stuff, so let's go to our world.cpp, which is getting pretty chunky. Like all these includes, man. And these are all necessary too. I tried to start removing some of them. World.cpp is relatively small. Like it's only 300 lines, but I need all those includes. But see you guys now. I know he changed his oil, not so... yeah. Gabe, I think that once you change to OpenGL 4.6, you should put core 460. Yeah, I'm pretty sure that's right too. Just gotta switch it eventually. Yeah, I'll do that in the future. It looks like I'm not using any 460 stuff explicitly, so we should be good there, but would be good to have that. Okay, so we're gonna have a static cube map, sky box, I guess we'll call it. So we're gonna go include cube map. Okay, so we got that. And then where do we generate the world texture? Because we'll just do all of that stuff at the same time. I think we do that. Okay, yeah, so we do it right here. We'll just do the same thing. And then we compile its shader too. So let's also do a cube map shader. So I've got a regular shader, static shader, cube map shader. So then we'll go ahead and we'll just say cube map shader dot compile, and this compiles it and generates it and everything. Okay, and then we'll say cube map. What do I call it? Skybox equals cube map generate cube map, and then we'll just pass in the top, which I'll say assets slash images slash sky, and then we'll just do day top.png. Cool, and then that's how we'll do it. So we'll do that. And I think it was bottom, and then left, and then right, and then front and back. Okay. Okay, we don't have these textures, by the way, yet. I still got to do that, which we will do in a minute. Okay, but I just want to get this set up. So we got that. That's all good. We should probably just embed a cube within the cube map itself and everything too, because that's just going to be the easiest way to do things. So we'll just have like a static array of... what does he do? He just does a unit cube, I'm pretty sure. Yeah, this is a skybox too, by the way, CGO clan. Okay, what does he do? He just... We'll need another VAO and VBO. Okay, cool. He gives us the vertex data. This guy is a Chad. Great. So we can just copy this too. So I don't have to write all those vertices out by hand. Awesome. So it looks like this is just straight up vertex data. There's nothing special embedded. It's all just unit data. Cool. So we've got all that, and then what we can do is we can add in a couple functions here. We'll just have like a render function, which does everything, because why not? And then we'll go into here and we'll say cube map render, and this is void. And I should also generate the VAO and VBO too when we're generating the cube map, so we'll add those as well. I don't think we actually need to store the VBO. We can just do the VAO. We might have to delete it because I don't think OpenGL deletes it automatically, but I don't know. We'll figure that stuff out later. And then renders could be const. It's just going to do some straight up rendering. And it will take in a shader. And I'll forward declare that here. And then, what's this? Endif is missing. No, it's not. It's right there. Cool. Okay, so then this will take in a const shader ref. Not super important to do that, I guess, but we're doing it. Okay, so then we'll include that up there. And then we can say shader.bind. And then, how did he do that rendering again? Because he disabled a couple things. Sweet. And then we'll just do this. And we'll pass into camera too, so that we can set that stuff up. Okay, and then for skybox shader, we've already got that. Cool. And then we'll bind our VAO. We will bind our texture, which is just our graphics ID. We'll draw. We'll then set the depth mask back to true. Cool. That is very simple. I like it. We gotta generate a VAO and VBO really quickly too, though. So let's see if I can do this from memory, guys. Let's see how good I am. If I've really learned stuff. Which extension am I using to check and highlight GLSL syntax? GLSL lint? I'm not sure. Let's check it real quick. I really like this music, by the way. It's perfect. Like, just low key enough, right? Okay. These are not what I have installed, are they? Oh, wait, here we go. Installed. Cool. So it looks like I've got... Oh, it's somewhere down here. Shader language, this thing. Shader languages support for VS Code v1.5. This thingy. So hopefully that helps you find it. Oh, I always forget to turn on my stupid mouse thing too. So now you guys can actually see a little bit better. But yeah, it has support for HLSL, GLSL, and CG, whatever that is. So if you're interested, you can go grab that yourself. It's nice and simple and it works, which is what I like. Okay, so let's see if I can generate this VAO VBO. We need to do generate vertex, or we need to do like generate array. What is it? GL gen vert x arrays 1 and VAO. GL bind vertex arrays VAO. And this is res.vao. Okay, because I'm using GLSL lint and it complains about hash type. Yeah, this is why I like this one thing. Oh, so you use Pragma instead. That's actually a good idea because Pragma is built in. Yeah, that's actually a really good idea. I should probably have done that and then I could use whatever I'm using here too. Okay, so we were binding it, then we do that. Then we're going to generate buffer. And then we'll bind the buffer. And then we're going to set some attributes. Actually, we're going to do like... Wait, what is it? It's GL set vertex attribute. Come on. I know I'm getting close there. Array attrib format. I gotta look this part up. I can't remember. Okay, let's go into render.cpp because I got some examples in there. Somewhere down here. Or no, I guess it's in batch.hpp. Somewhere up here. Not that. It's this. Okay, so we create vertex array, bind vertex array, generate a buffer, bind the buffer. That's just buffering the data. Oh, cool. I've set up like a whole thing for vertex attributes. Oh, that's pretty cool. It would be nice if I abstracted this a little bit more, but for now, it is what it is. Okay, so vertex attrib pointer, then enable vertex attrib array. So, yeah, that's actually pretty cool because then I can use it. Like you can see how I use it here, and I just do that. I think Cherno did something similar. But yeah. So we need this back into here. This is going to be, we'll do slot 0, I think is what it was. Yeah, slot 0. We have 3 floats. Size of float times 3. I think we could set that to 0, and then it knows it's tightly packed. Is also okay. And that's 0 as well. Okay, and then we'll just do GL enable vertex attrib array 0. Just double check that. Yep. Okay, and I think we should be good there. We need to buffer the data too. That would be good. So we got that. GL buffer data. GL array buffer. Size is going to be size of what did he call it? I guess skybox vertices. Okay, and I think we should be good just doing that. It gets the actual size. Data is skybox vertices, and then usage is GL static draw. Okay, cool. So that should be all we need. Now we have the VAO, we have the VBO. We have this thing which should render it. So then if I go into the renderer or the world and we've got all this set up, I should be able, oh, we also need to pass in the cubes map. Yeah, okay. So we also need to do this shader.upload. What was that? 2 map4s, projection, U projection, and then camera.calculate. That, and we'll pass that in too, and then the view. And I think this is calculate view matrix. We might be able to just pass that stuff into. Let's see, world.cpp. So when we update, okay, we get the camera, we do all that stuff. Okay, we have the projection and the view, so we can just pass that directly into our cube map here. We'll say taking a const glm map4 ref and that, copy that, paste it. Not that many times though. Okay, cube map, we're good. And then we can just pass it that, and we can pass it, doesn't like this for some reason, that, because I have the semicolon there. Okay, cool. So that should be all good. And then when we go into world, we can go ahead and just say somewhere in here, before we render anything else. So I guess we should do that very first thing here. Render cube map. Well, actually, we should probably do it. Yeah, we'll do it. We'll do it right here. So then we'll just say skybox dot render, pass it its skybox shader or cube map shader, projection matrix. Okay, we also need to upload the skybox too. I almost forgot about that. In here, we also need to do shader.upload. What is this too? And then we'll have to do this too. We are not going to worry about environment mapping for now. But when we actually upload, because we have this sampler cube, GLS open GL uniform. I think 1i is what we would use. Let me check the chat real quickly too. Okay, yeah, you'll have to let us know if the pragma works even if you don't remove it and stuff too. So if I look down here, we should see somewhere down here. Okay, GL uniform 1i are the only 2 functions that may be used to load uniform variables defined as sampler types. Okay, loading samplers with any other function. Okay, cool. So we just need to use 1i to upload the sampler. So we could just say .upload 1 int u skybox, and we'll give it our VAO, which, or no, our graphics ID. Okay, cool. And I think that's all we need. Yep, that's good. Whoops, that's good. Okay, guys, If this works first try, it's not because I did anything right. It's because I copied too much code. So let's see if this works though. I need to add in the textures. So we need an assets / images. What is that? Sky. And then we're going to go in here. We need a day, top, bottom, left, right, and back. So let's go and download a cube map. And we'll just use whatever we get. Textures, hummus. Okay, cool. This works. Let's find something cool. I probably shouldn't be too picky about this because it doesn't really matter. Let's do the snow. Now let's do this one because this one's kind of interesting. Okay. I'll download this to my downloads. Okay, we'll extract that. Cool. Oh, cool. And he even tells us which is which. Sweet. So we'll just move that. So negative X is left. What did I... Wait, what did I even do? Because I don't even think I really assigned those. Okay, so... Oh, I need to set the texture types here too. This would be important. Okay, this would be something we would forget about. Okay. So we also need to set the texture type. And then we're going to do texture type, cube map. Okay, so this is top. So this is going to be positive Y. Cool. So this is the one thing that I forgot about that would not have been good. Negative Y. Texture type. Left is going to be negative Z. What did I just do? I think I did page down. Okay. Positive Z. This is going to be positive X. And this is going to be negative X. Okay, cool. So now we have all those types set up too. I think that was the last thing. So now if we go into here, this should be... If we do this, I said top was positive Y, so we'll do day top. Bottom was negative Y, so this will be day bottom. Left was negative Z. Positive Z is right. Front is positive X. And then back is negative X. Cool. So that should be good. And now if we go into a world, we should have a cube map, possibly. Okay, so you have to remove the pragma, but before compiling. Okay, well that's pretty cool still. So what did I miss? Did I not implement it correctly? Qmap.h render. Inside of here. Yeah, I'm pretty sure this is the same definition. Yeah, okay. This is coming from world. Did I not include Qmap.h? Or is it not compiling that for some reason? Qmap.cpp. Okay, yeah, I definitely have it included here. I think I just have to regenerate my project file. Sometimes it does this, which is kind of weird. So we'll just rebuild that. Okay, let's see if it works now. Nope, still not working. Okay. I think the error actually showed us something better. Okay, first scene using class, now using struct. Why does Visual Studio do this? This does not tell me anything. This tells me what's happening. Like, why? I don't get that. Okay, so I just need to change that to struct. Thank you. That is so much more helpful than whatever the gibberish you gave me before was. But yeah, whatever. Okay, so if we go in, okay, what happened now? We missed something. STB failed to open image. Assets slash images slash sky slash. Oh, I should have it in sky. Where did I put it in? Assets, images. Okay, I did put it in sky. Day top. Oh, these are JPEGs. Yeah, that would be helpful. Use the right texture extension. Does STB work with JPEGs? I think it does. Hopefully it does. That shouldn't be a problem because I just compiled, so I don't know what it's complaining about there. Let's just change this to JPEG. Okay, let's do this again. Okay. No, what did I get here? So I think I had problems generating it. Invalid target. Okay, still rendering everything else. Okay, that's good. That's coming from render.cpp line 449. That's coming from the, oh wait, yeah, that's just because that's where the error is getting logged. Okay, never mind. Okay, so it looks like we're getting invalid target. So did I screw something up with this code? So what do? We do generate texture, then we bind it, texture Cubemap. Okay, that's fine. And then when we do generate, let's see what this does again. So we do this. We don't get invalid texture type, so that's good. That would usually mean that something's wrong. Let's go here and see what we're getting. Okay, so this is not helpful, and this is not what I want anyways, because we're not in the right place. Okay, there we go. Okay, which one are we doing here? We're doing... That's not what I want. Let's go again. Which one is this? Cubemap positive Y. Okay, cool. So this is one that we would be looking. So we should be getting Cubemap positive Y. So that's GLFW Cubemap positive Y. Okay, what is the appropriate thing for that? Just so that we can see what that value should be. Yeah, let's go here. Let's do, what is... Okay, positive X. There we go. So we'll go back up to here. So positive X. Why is that undefined? That shouldn't be undefined. Actually, it should be because that's a compile preprocessor. Okay, let's go back there. Okay, what is this? This is that. So positive Y is 34071 is what we should be getting. What are we getting inside of there? We are getting 34071. Okay, so that's correct. Just double check that. Yep, 34071. And wherever I was, right here. Okay, 34071. Okay, so that's right. Did I get an error already? I did get an error already. Okay, so something else was bad. What did I even do up to this point that would have broken that? Were we breaking earlier? We might be breaking. Let's remove that breakpoint. Go into here. Let's go right here and see where that error starts to pop up. Okay, so we hit this. Do we have any errors? We do not. Okay, so it's definitely happening in here. So we generate texture, bind it, that's all fine. Okay, so then we go into here. This sets all the default values. That sets the type. That sets the file path. And then we go into here. And then we go into here. We have not hit any errors because we haven't done any GL calls. So this is all good. Okay, so this is probably where we're breaking. We still haven't run into anything bad. Okay, so we skip. Okay, no, we don't skip min filter. I should set the min filter to none and the mag filter to none. Let's fix that. Yeah, so we'll do that and that, and we'll add those. Why can't I copy that? Copy. Thank you. Okay, there we go. We'll add that there, there, there. Okay. So if we do this again, do we get those GL errors? Okay, we're still getting one, so let's see what's going on there. Wait, does he still generate texture objects for each texture? Because I might be missing that part completely, and that's why we're getting this. No, he just texts the image immediately. So he generates one texture object, binds that texture object, which is the cube map, and then we just text the image to there. Yeah. Okay, so it must be something else in here. Let's see. Okay, so if I go into here, we do all this, that's fine. We do all this, that's fine. That's also fine. And so is that. And that. Okay. Now we go into here. Okay, no errors. We're good. So then we go into here. We skip all those, that's good. No errors. That's good. Then we do this swizzle mask. Okay, and I'm guessing this is where we get an error. Okay, so let's just add a swizzle mask none thing. So if we'll go into texture.h and we'll just fix that real quickly. I don't think I'm even using swizzle masks actually. Let's get rid of this. I'm not even using that right now. Let's not worry about it. If I use it in the future, then I'll worry about it. So let's go back into here. Okay, did I hit any errors? No errors. Cool. So let's just run that now and see what happens. Okay, so we ran that okay. I'm still not seeing any cube map though. And are we getting any errors? We're not getting any errors. So, oh, it's because I'm doing GL clear color after that, I bet you. Okay, let's go back into world. Where do I do clear color? No, I think I do clear color before this, so this should be good. Who calls world update? I think that's application CPP. So it's called scene update. Okay, yep. So this is where the clear color happens, and then we call update here. Okay, yeah, and then that's all good. So then the color should be cleared, and then we call render here, which should do this and all this. We should be good. Maybe it's because of the view. Okay, because the skybox is drawn on a cube, we'll need another VAO, VBO, and fresh set of vertices. A cube map used to texture a 3D cube can be sampled using local positions of the cube as its texture coordinates. When a cube is centered, each of its position vectors is also direction from the origin. Okay, for this reason, we only need to supply position vectors and don't need texture coordinates. To render the skybox, we'll need a new set of shaders. Okay, so then we give the projection, the view. We get the position. Oh, okay, wait, what's this position? Yeah, that's what we just, that's just the vertex attributes. So that should be fine, I think. SC Woods, I see you haven't bothered setting up IMGUI for this series. Yep, go customer, go home. Exactly. I wanted to do that just because there's not really too much of a need for it right now in this. So because we're just doing a game. We're not really doing editors and stuff. GL position is projection times view. Okay, so that's all right. And then we do frag color, text chords. Okay, rendering the skybox is easy now. Blah, blah, blah. We have a Cubemap texture. If you run this, you will get into difficulties though. Okay, so we want the skybox. This is what I was wondering. We want it to be centered around the player set. No matter how far the player moves, the skybox won't get any closer, giving the impression that the surrounding environment is extremely large. Yes. The current view matrix transforms all the skybox. Yes, this is what I was wondering. So if the player moves, Cubemap moves as well. We want to remove the translation part of the view matrix, so only the rotation will affect the skybox's position vectors. Remember from the basic lighting chapter that we can remove the translation section of transformation matrices by taking the upper left 3 of the 4x4 matrix. We can achieve this by converting the view matrix to a 3x3 matrix, removing translation and converting it back to a 4x4 matrix. This removes any translation but keeps all rotations transformations so that you can still look around the scene. Okay, let's try that out. I think we could do that in the shader too, but I'll do it here for now. So he's literally just doing mat 4, mat 3 for the view. So we'll do a mat 3 and a mat 4. I was wondering that. I was like, how is this going to work right when the player moves around and stuff and we're passing in its view matrix and it's a unit cube? So that makes sense. Okay, it's definitely doing something different now. We're getting black. This is Cubemaps, guys. Doesn't it look great? I'm guessing what's happening is for some reason we're not loading the textures properly. Looks like they just don't like that textures. Let's look for a PNG Cubemap. Or, I don't know. Amazing, right? I know, right? This is what we've been waiting for, these beautiful Cubemaps. He's using STB here too, and he's using JPEG. So STB definitely works with JPEGs. But I'm just not uploading it properly, I guess. He's using RGB data. Could that be why? Am I using RGBA data? Let's see. I'm expecting... Do Cubemaps work with RGBA data? Does it even matter? What do we do here? We are using the A component of our texture. Let's do vec for that .rgb, and then we'll just set A to 1. And we'll see what happens there. Still doesn't work. Okay, let's check it out. Let's see what our pictures are, because it could totally be something wrong with those. So this is a JPEG, and details, it is 2K, that's fine. 24-bit depth, so that should be RGB, not RGBA. Yeah, so that shouldn't matter too much, I don't think. Let's just make sure it's getting it set up properly when we actually load it. Okay. So inside of Cubemap.cpp, when we're generating it, let's make sure that this does the right thing. So if we go into here, past all this stuff, this is the one bad thing about doing something like that, where you have a functional style of stuff, because you can't really break on a certain function. Okay, so generate from file. We load it from, this is assets/images/sky daytop.jpg. Okay, and we pass in the width. What width did it get? It got 2048 by 2048. That's all correct. 3 channels. That's correct. Okay. And it would have said it failed to load the image too. So yeah. Okay, so then we set to RGB8 UI. That's an unsigned integer. Is that what I want? I think that is what I want. He uses unsigned byte. Should that be an unsigned byte? I don't know. So we bind the texture parameters. That doesn't matter. Internal format, what does that give us? We get, that looked like RGB8 UI. Yeah. So it's giving us RGB8. That's fine. And then it's giving us RGB. Believe that's fine too. Okay, yeah, and then I use GL unsigned byte here. So that looks like that's fine as well. Okay. So then we just do internal format. Well, that's not going to make sense. 2048 by 2048. Pixels, definitely got pixels. And we're saying it's an unsigned byte, which is what we get returned from STB anyways. So what's going wrong there? Is it because of this? Did I set these up properly? I'm pretty sure I did. But that could totally be it, because if it's stretching the texture and I don't have those parameters set properly, that would break things. So let's go back into the cube map. So we generate, we bind, we generate all of these, or we text all of these, and then we text all that stuff. Am I unbinding the texture when I do this for some reason? Doesn't look like I'm binding. Wait, okay, what's this do? Yeah, it doesn't look like I'm unbinding anything here. The texture or anything like that, or changing GL state. This could still be bad technically, I guess, but we shouldn't be hitting that. Yeah. Dev, yeah, that should be unsigned byte. Okay, yep. Did not program Minecraft in OOP type of style. He did, okay. I have no idea on that, so I haven't seen his anything that he's done with that. Let's see if, I'm trying to think. There's no way that we can really test to see if this is working because they're all bound to this cube map. So what we're doing is like the simplest test that we could do. Let's see if he has his full source code just so that we can take a look at that and make sure I'm not missing something. Okay, let's see. Usually he pastes his full source code somewhere. Oh, here we go. So oh, that's for the cube. Okay, cool. So we got the skybox here. Okay, so he gets the cube, skybox VAO. Cool. So we generate that, vertex arrays, buffers. Am I doing that correct? Because I could be doing that wrong, and that wouldn't be good either. So I generate vertex arrays. I generate buffer. Am I binding the VAO? Is that what I'm missing, possibly? No, I'm binding the VAO, so that's okay. So we generate vertex array. We bind it. Generate. Oh, and then he generates a buffer. And then he binds the vertex array. Then he binds the buffer, which is an array buffer. Size of skybox vertices. Oh, he passes an address to this. I don't think that should matter, but let's try it because maybe I wasn't buffering the data properly. If that's the case, then this is exactly why we need to be careful about confusing arrays with pointers in C++. No, okay, so that didn't fix it still. Let's see what else. So we bind the buffer, we buffer the data, GL static draw, that's what I did. We enable the vertex attribute array. He does it before he does the attribute pointer, but I don't think that should matter. Yeah, I don't think that should matter. It's 0, 3, float, false, 3 times size of float, 0. Maybe it's because I did this. I assumed that would do, this should be just 3 times size of float. I assumed that that would tell OpenGL it's tightly packed because it does that in some other OpenGL calls, but maybe it doesn't do it there. And that would explain why we get nothing. No, okay, so we're still not getting it. Okay. So float, false, 3 times size of float. Let's see if it's just rendering anything first of all. I guess that's probably a good idea. Let's do... I mean, it is rendering stuff because we can see that. 0.8. So this should set it to like reddish. Never assume. That is true. It leads to assumptions. That is also true. I think my assumption was correct in that case though. Okay, yeah, or a yellow, I guess. So we're getting yellow, so it's definitely rendering stuff. It's just not sampling the texture correctly. Okay, so there's nothing wrong with the vertex data. Vertex data is fine. That's all fine. So it's got to be something that's going on here. So let's see what else he does. So he gets all the file paths. That's all good. Then he says Cubemap load faces. Use, he says set int texture 1 to 0, set int skybox to 0. Okay, so we have this sampler cube, use skybox, and what I do is I say when I'm rendering it... Oh, wait. Yeah, that's right, that's right. We set it to the graphics ID? Wait a second, is that right? I don't think that is right. I think... that might have to be 0. Possibly. Because textures are always weird and they always confuse me. It's like the texture slot is what you want to bind there. Yeah, okay, so that's what it was. And my images are flipped. Cool. Cubemaps, guys. It's working, but it's not working good because I have something wrong. So, yeah, that always confuses me. It makes no sense. Why would you bind the texture slot when you have the graphics ID? But I guess it kind of makes sense. Okay, so what's wrong here? Is this the top? Is the top correct? Because we need to find out which ones we have flipped. So top should look like that. Top does look like that. That's good. Right. Let's see. This is, we're moving in the Z direction. We're going Z positive this way. So Z positive should be right. And we should get something different than this, I think. Yeah. Nice, cube mapped, yeah, right? Top is correct. Yeah, when setting uniforms, you need to use the slot, not the texture ID. Yeah, that always confuses me. It's so weird. Okay, so right is wrong. It should be that. And then left should be that. I think right and left are possibly flipped. None of those look right, actually. Let's do this so that we can actually see things. Yeah, this is all top. Wait a second. That's top. That's top. That's top. They're all top. Why are you all top? You should all be different things. Did I use the same? I think I might have done something stupid here. Yeah, okay. They're all top. Why are they all top? It's because I'm using top everywhere. You know, that makes sense. Let's change these to the right things. Well, that's good. At least it wasn't an error in the actual code and stuff. It was just dumb mistakes that I make, so... See, Voxrifts, if I make stupid mistakes like this, there's no way I can judge your code too harshly when we go and review it later, because, yeah, I love it when it's something that simple. That's true. Okay, cool. So, we've got this horrible cube map for our game. What I want to be able to do is I think it would be super cool if I could just, like, press a button here, or, like, in the future, I could, like, do a command, and I'll say, like, slash, I don't know, generate cube map, and that will generate 6 textures depending on where I'm at, and then it'll just like take a snapshot of each side, output it to a buffer, and then output those to images, and then we can use those and stuff. I love how big that guy is just watching over your world, right? Maybe we should leave it. This is like for aesthetic purposes, right? This is how we'll keep it. But yeah, and I think that would be probably better in the future. Well, if you guys like it how it is for now, we can definitely leave it this way for now. Okay, we have Cubemaps working. Let's commit that, and let's add some trees, because I want to add something to our world, and then we will call it a day and take a look at Voxelrift's code. So we'll say commit, add Cubemaps. Okay, so we got that done. And then I'll add that functionality later and stuff, and hopefully that'll work right. Yep, that's how ants must feel. True. First build a shrine to the rock guy. Okay. Cool. So we've got all this done. We'll build the shrine later. Let's add trees to our world generation really quickly, because I think that would be cool. I'm going to go ahead and just delete some worlds that we've got, which is actually going to be in a different thing. So we'll go there and here. And since I'm going to be generating new world techniques, I'm just going to delete all the worlds that I currently have. Cool. So we're all good there. It looks absolutely awful and I love it. Yep. Okay, so for world generation, why is this still telling me that's wrong? That's not wrong. I don't know. Okay, if we go into chunk manager.cpp, we can go to generate right there. Okay, so this is where we generate our data. And what we can do is, as we're generating, if we hit a block, we're just gonna do the simplest tree generation that we could ever do, right? For now, and then we'll fix it later. So what we're gonna do is we're gonna check and see. So this is if we are on grass. Okay, so this means we're at the max height. Okay. And this takes in X and Z, so no matter what, we'll be able to tell if we're at the max height. Yeah, cool. So then we can determine how big a tree is. So we'll just sort of launch something. So we'll say if Y equals max height, let's generate some trees. So we'll just do like a random number to determine whether or not we're gonna get a tree. Do I have random included in here? There we go, rand. So what we can do is we can say, what does rand return to? We should double check that very quickly. Let's get out of that. Get out of that. And that. Rand C. Okay. Forgive my ignorance, but I thought C++ used HPP header files. Or you can use either. You can use either. Includes don't care. But the typical convention is just like you use HPP if you're doing like a template header file, since it contains C++ code, or if your header file contains like C++ code, you mark it HPP, and then you just mark it H if it's just purely like for declarations and stuff. Some people do it differently, so it's all just based on whatever you want. So I try and follow that convention though, just to make it a little bit more intuitive what's happening. MD Dev. Gabe is over here pulling on Ultron, just deleting whole worlds. Yeah. Sometimes you got to do that, right? Okay, so rand just returns a big number. Okay, so we can just mod it to figure out something. So what we'll do is we'll do the most dead simple thing. We'll say int generate tree bool generate tree equals rand mod 100 equals or is greater than 90. Do we want to do that? That's like a 10% chance of a tree. We'll see how this looks. So basically we have a 10% chance of generating a tree for each block. And then we can change this. And then int tree height equals rand mod 6. So then we'll generate the tree's height and all that stuff. And then we'll go for int y equals max height. Actually, we'll have to do a different int. Tree y equals max height until tree y is less than tree height plus y, tree y plus plus. So we'll do this, and then we'll just generate the stumps for now. So we'll say block data to 1D array x tree y z equals what is our logs IDs, somewhere in here it's 8. Okay, so equals 8. Do that, and then once we do that, we can sort of generate the leaves and stuff, and then we have to modify our air block placement, because yeah, this places an air block. Else if block data array expansion dot id equals 0, we could just do if not that dot id. Okay, cool. So basically this will just check and see if we haven't placed anything there. So if we do this, we should get like stumps popping up everywhere, and we'll see how that goes. Jumping ropes while jumping ropes on a spherical planet in Earth in space. Life does not get much more strange than that. That's true. While watching a stream on programming Minecraft. Yep. Okay, so test trees. So let's see how this goes. Wow, that's too many trees. Definitely working though, just way too many. So let's turn that down a bit. If I do rand mod 100 is greater than 90, that's like a 10% chance it'll generate. Yeah, I think so. Right? That's what that should be. We'll do a 99, 98. So that's a 1% chance that it should generate. Possibly. Yeah. Who knew that would be so big? Okay, let's go ahead and just... I exited out of that other thing. Why did I do that? Percent app data. Minecraft clone. We're just going to delete that again. Sorry, I've got to do it. Okay, so... Test trees 2. Let's see if this is better. Okay. What the heck? This is like way too many. I would think a 1% chance would be like 1 out of every 100. Oh, you know what it is? It's because I'm doing 1 out of every single block that we check. Wait, no, this should, yeah. Only happen if we hit y equals max height, and then we call rand. This makes no sense. Okay. So y equals max height only on that specific block. And then we call this, which should call rand only when we hit. So this should only be running once for every block on the surface, which means that I would expect for like every 100 blocks on the surface, we should see 1 tree stump. Is it voxel code you're going to review? It is. Yep. That's definitely not 1%. Yeah, I know. Which is really weird. Let's just see what's happening in here, I guess. This is what they say. This generates V1 in the range 0 to 99. Okay, let's just do this. We'll say print int number equals rand mod 100, and then we'll do that, and then we'll say that. Okay, let's just see what it's generating, because I am curious now. Hey, your game engine started to help me get through uni project. Thanks. No problem. I'm glad it helped you out. Hopefully you were able to build some cool stuff with it too. Maybe rand maxes with a weird value. That's possible. I'm following the way they said to do it though, which is why I'm kind of wondering. Okay, these definitely look like reasonable values. They're all random. And it's never going to finish rendering now because of all of those values. I'm just wondering if it's running too many times, and that's what's causing this. Let's stop that real quickly. Okay, so let's stop doing that. And then I'll load that back up. We might have some weird stuff because I paused that in the middle of it, so it might not have... we might have corrupted data. No, yeah, it's still just like way too many. This was supposed to be easy to do. Maybe rand maxes with a weird value. Are you going through the max height for some reason? Oh, I don't know. That could be if y equals max height, right? Okay. So we say max height equals whatever was generated here. And this is generated based on the X and the Z position. Well, that would make sense if we're doing something like that. So we're saying if y, I mean, the reason I don't think that though is because we're saying if y equals max height, we do this here. But, because we're not feeding y into here at all. So that's the one thing that I'm kind of wondering about. Let's just do this. Maybe it's that loop that I'm doing. So let's do block data to 1D array x y plus 1 z dot id equals 8. Let's do that and see what happens. Because it's very possible that's broken because of something that I did weird. I really need to add a delete world here. Trees 3. Okay. No, that's definitely not helping still. Oh, it's is it because I don't have this inside the if statement? Yeah, I'm so stupid. Do we see the problem? Do we see the problem? Why did I not see this? If generate tree. No wonder it wasn't working. I don't know. Guys, sometimes you do this type of stuff and you're just like, what am I doing? Yeah, that would help if I'm actually checking. Yeah, right? This is twice in the same stream. Something's not going good with me today, I guess. Trees 4. Now we should get 1% of blocks has a tree on it. And if we look at this, there we go. That looks much more reasonable. And you can see there's a couple trees up here. Yeah, okay, cool. Look at that. Now it's finally working right. I wonder why they're all up here, though. Nothing down there. I guess that's just the way it is, right? Yeah. Okay. That's kind of weird. Why'd you generate in the ground? I think we should probably make it so that we can't get any one height trees. Like, so we'll do rand mod 6. Oh, yeah, that's plus 3. So that should give us between 3 and 8 tall. Okay. And then we'll go from tree y equals max height plus 1 up until that. And we'll also make sure that the tree's not going to go above world limit, because that is a possibility right now. If generate tree and max height plus 1 plus tree height is less than world chunk height. Okay, cool. And then we'll do like a little bit higher distribution. Let's try 94 and see how that looks. Herobrine Forest, true, right? One black high tree, yep. I see them at the bottom also. Yeah, there was a few at the bottom there that I noticed as well. Okay, let's do trees 5. It's nice that we can do world generation like this now, and it should be pretty easy to just add this stuff in. Cool, I think that's a pretty heavy distribution. We'll add some leaves at some point and see how that looks, because this might be a little bit too much. And then we'll add some birch trees in there too, just so that we get a little bit of a variety. Let's go, let's do like a 96, so there's a 4% chance. And then for generating the leaves, that is pretty cool forest. Oh, cool. So for generating leaves, what do we want to do? This should be really quick. Dead forest, true, but we're about to fix that. So we'll do like a int. We'll say int leaves start equals, and then we'll do the tree's height minus a random number, random mod. I don't know. What do we want to do? Like 3 blocks? There's a 3 block variation. Maybe 2 blocks. Yeah, this would be 3 blocks. So we'd get 0, 1, or 2. So it could start at tree height. We'll do +1. So it could do 1, 2, or 3 blocks below. But we also have to make sure it doesn't touch the ground, because that'd be weird. So we'll do like a GLM clamp. That and 2. So it can't be lower than 2 blocks below. 3 is what we'll do. So we want to clamp that 3. Max value is world chunk height. Okay, doesn't really matter, but yeah. That should give us clamp. Okay, this is fine. There we go. Cool. This looks like the green areas that is implemented into large cities. Yeah, it does, right? Okay, so we've got the leaves start height, and then we'll get like the leaves end height. I guess we should call this bottom y, top y equals, and then we'll do something similar. We'll do +2. Yeah, +1. I think is fine. We'll see how this looks, and then we'll do chunk height. Cool. So that should be good. And it doesn't like this still because I didn't add a minimum. The minimum will be the tree's height. We have to at least cover the tree's height +1. Okay, cool. So, and we'll fix that. Yeah, I think that's all good. Yep. Okay, cool. So we'll do that, and then we'll go ahead and just go for int leaves y equals leaves bottom y until leaves y is less than or equal to leaves top y plus y, and I'll have to do the plus y there too. We'll do that. Equals bottom y plus y. Okay. And this should be less than or equal to as well. And then for each of these, we'll just generate like a random radius around it, I guess. I don't know. We'll just kind of loop out. For now, we'll just do like a couple of sticks, right? So we'll just do like leaves on the outside of the tree bark directly. So we'll say block data to 1D array x minus 1 tree or leaves y. z.id equals, I think it's 9. And then we'll do x plus 1, z minus 1, z plus 1. And technically we do need to make sure that we're not going to go across a chunk border right now. We'll fix that in the future though. So we'll just say if x minus 1 is greater than or equal to 0. Do that. If x plus 1 is less than world chunk depth, do that. And then we'll say if z minus 1 is greater than or equal to 0. And then if z plus 1 is less than world chunk width. Okay. So we should just get some sticks with leaves. Okay, so this is trees 6. Cool. I love them. I think this is good enough. Okay, this will be trees for now, and we'll fix it at some point in the later. But we do have trees in the game. That background is quite distracting, so I'm gonna have to change it in the future. But yeah, we've got trees and all that stuff. We've got lighting, kind of, for real. Hopefully it still works and I didn't break it somehow. So if I go and just build a little box, we should get encased in darkness. Awesome. It works. That makes me happy. Cool. So yeah, we've got all this stuff. I mean, it's really starting to turn out. Yeah, close enough, all right? It's good enough. You also have cars and a big statue. That's true. Minecraft doesn't have cars or big statues, so I think we've outdone them there. We've also got a porta potty, so we got everything. Everything you could ever want. So I think this is going to do it for now. Let's go ahead and we'll just say like added trees, and we'll push that. Added very bad trees. Okay, and then I think now is the time we've all been waiting for. I'm excited to try this. So, Voxriffs, do you have a link to your GitHub? I think I should be able to find you. Because I think you've contributed a couple times. Let's just do voxel riffs. No, we didn't find anybody. What about users? There we go. Okay, here we go. Pixel riffs. This is you. Okay, and then I'm guessing this is gonna be Rift. Oh, you changed it. It's not Rit F. It's Rift now. Okay, so we've got this. Getting started, clone the repo, generate build.bat. Sweet, cool. So this should be easy. We'll see if this works out. I'm gonna go ahead and close this down for now. And we're gonna go into here. Actually, I'm gonna go into temp just so that, yeah, okay. Rift is what this is called. Okay, so you did change it and you added some examples today. Okay, cool. So we shall see. Let's go into here, and we should be able to just clone this and then run build.bat. So okay, so that's all good. Let's just move all that up. Okay, and I think I can remove that. Cool. They aren't examples. You need GCC or Clang, by the way. Okay, I don't have GCC or Clang, so I might have to install that. I think I might have GCC though, or maybe Clang. I don't know. Let me just see. Yeah, so this just looks for Clang. Let's just do that real quick. Clang download. You don't like MSVC? That's not very nice, Foxworth, but it's okay. It's annoying to use that, so I don't blame you. Okay, let's see. I just want to download it. Okay. I'll find rather hard. Yeah, you find it rather hard to read other people's code. Yeah, we'll see how I do. Because it can be tough too. Okay, which one do I want? I'm pretty sure that I want this executable, the 64-bit executable. Okay, let's download this. I'm just gonna put it in here. Let's see what this is. I might just have to add this to my path, or just put it where your build file is, and that should be good. Okay. Okay, yeah, this is a setup. Cool. We'll set it up real quickly. Oh, I was wondering what my computer was going to do when that happened. So it just blacked everything out for you guys on the stream. It just asked me if this was okay. Okay, so let's set this up real quickly and then we should be good. You should have said that sooner. No, it's all good. I should have this stuff installed, honestly, because there's been a lot of times where it's like it would be beneficial for me to have another compiler and I just don't. So I've been needing to do this for a while anyways. Okay, let's add it to our path. Okay, this is all good. Cool. That was fast. Okay, cool. Almost. Doesn't BS provide a Clang compiler? It might. I don't know. It definitely isn't added in my path though. Let's just make sure I actually... Cool. Yeah, so we should be good now. Okay, it's building. Okay, we got a linker error. What did I miss? cpcom.exe. Is that just something that... Nope. Where do your build files go to? Is that something for forcoder maybe that I'm missing? Oh, right, make dir bin. Okay. There we go. So let's do that. Okay, there we go. Thanks. That's what I needed. Okay, so we got this. So I'm guessing I can just run cpcom on any of these. So if I go and say bin /cpcom, No, you're not gonna find it. It's because I'm using // bin/cpcom. There we go. And if I do /examples/ let's do structures. Okay, so it did something. Did it output a file here? It did. Generated.c. Cool. Let's check this out. I'm gonna open it up with VS Code, and I'm gonna close all this stuff out too. Sweet. So it looks like it's working good. Let's take a look at the code and stuff too. I'll try the other ones out too and make sure that those are working as well. So let's just delete that real quickly. I'm hoping I could delete that. I don't think that was bad. Let's also go ahead. We're going to open this folder just so that I can actually look at the code. So if we go there. Okay, cool. I trust you, voxel riffs, so we should be good. Okay, so if we look at the source, this is the source, and then I'm gonna close that out now too. We don't need that, so we should be good there. Let's go into our examples folder, and then I'm just gonna do whoops, bin/cpcom, and then let's try some of the other examples too. So we'll do fizzbuzz. Okay, and we get this. And it looks like that's good. Cool. Okay, and then let's see what fizzbuzz.cp is. Okay, cool. So it looks very similar. It's just generating those includes and everything for us as well. That's cool. I'm sure it's doing a lot more stuff, so we'll take a look. You can compile it easily to out.exe with Clang, by the way. Just do clang.generate.c-o. Okay, cool. Generate.exe. You gotta delete generate.c files when you build the entire project. Okay, yeah, that makes sense. So if we were to do then clang, let's see what you wrote there, generate.c, so we'll do .c-o. Okay. Nope, wrong thing. ./generated.exe. Sweet. Okay, cool. Working all good. This is pretty cool. So I guess the next logical step is for us to take a look at the code. So let's see, where is the entrance for this? There we go, main.c. Cool. Okay, so you read the file. I'm guessing I'm probably gonna see a lot of similarities to possibly the what is it, Bob Nystrom's books, Crafting Interpreters? I don't know. You guys are technical when it comes to computers. Yeah. You gotta delete generated.c file when you build the entire project. Okay, cool. So we've got this read file. So you read the file, put it into a buffer, and then you set the bytes read equal to 0. Okay. So this is just, oh, that's just your read file function. I'm not even looking at the main function. Okay, this is gonna be a journey. We'll see how good I can do reading through the stuff. Okay, so then you just check to see, okay, so you print out this if we don't provide something. Cool, I like it. Good message. Okay, otherwise you start lexing the file. Okay, so then we got CP lexer, we've got CP parser, and we got CP LA test. So what is the difference between these three different things? And I'm guessing you probably have this defined inside of your build file. Yes, so we're in debug and we're doing CPLA test. So we're going through, let's see, I lost the main file. We're going through this one. So this emitter. So many similarities. Yeah, yo, give me, it's CP latest, by the way. Okay, so yeah, we're using CP latest. That makes sense. So we go through this path and we go E emitter and then E initialize. So this is your bytecode emitter, I'm guessing, or whatever you use, and then you generate it based on that bytecode. So we have E initialize, which I'm guessing up here somewhere. This all looks familiar though. This is cool. Oh, this is just what emits the C code, C++ code, or C code. That's what it looks like. Okay, so initialize, so you basically just initialize the structure. which is you have a parser in there. So if we look in here, okay, so you've got this precedence, value type collections. Oh, cool. Dang. So this is pretty fleshed out. You're doing pretty good with this. Okay. And then you got like, so this is for an expression. So you have type, return type, and then you have all the literals. Oh, cool. And you did a union here. That's good. So is a string for transpiling reasons. Okay. Cool. And so this is basically what an expression can be, I guess. You have the type of the expression, the return type of the expression. Interesting that you have the return type there too. So you can automatically infer types, I guess. I also have just parser and just lexer. That's what the other specific defines are. Okay, cool. So then we've got character literals, string literals, type names. So you basically just stuff whatever it is into here. And then whether it's a binary operator, I'm guessing is what this is. And then whether it's a function call. Cool. And then you have like the different nodes. So these are all your abstract syntax tree nodes, I'm guessing. Type checking happens while parsing. Cool. So you do type checking everything. So if I were to go ahead and if I were to return the wrong thing here. So let's say I returned a string. Let's see what happens now. Okay. This might be undefined behavior. I don't know what I'm doing here. So let's see. So if we go bin, that was fizzbuzz. Okay, so it looks like it did it all right. What did we get here? Okay, so we just returned the string still. Okay, so that's not good. Yeah, type checking while happens parsing. Okay. Whoa, so should it not be doing that? Should it be doing an error if we do something like that? Let's do 0 again here. I'm not sure if you have error handling. Let's do that and then see if we get an error there. Okay, yeah, so we do get an error there. So it looks like you have some stuff and it shouldn't happen. Okay, yep. So we get the error telling us what's wrong. This is cool. You know what's really cool too, if you want to support this, I don't know, but if you basically do something like this and then you do like, instead of doing that, you get the, so this is line 16 is what it was saying. So that's this line, I'm guessing. Oh, wait, no, that's just saying that because of that. So if we were to do this one, line 14, it would be cool if you had something like, you print out the line. So I guess we just do that whole thing. And then you just say like, here, you know, I know in crafting interpreters, he has this and it's actually not that hard to implement, especially if you already know the index and everything that this is occurring at. So it'd be really cool if you could implement something like this. And then that way, you know that you're like expecting a semicolon right here and it's just a little bit nicer. I hate error messages in most languages. So if you can also improve error messages in your language compared to C++, that's also amazing. Comments don't work, by the way. Okay. Well, that leads me to my next thing that I kind of want to check out, which is how you're doing your lexing. Yeah. Ooh, big switch case, but this makes sense. Okay, so you're basically, this is getting the string from the type. Okay. Oh, so this is for debug messages, I'm assuming, so that you can write debug messages. I saw an interesting talk on, what was it? It's what's the one game dev conference? What's it called? So those are enums, debug enum names. Because I saw a cool trick that you can do. GDC, yeah. So let's do GDC. Maybe it's this. Okay, yeah. So you can do some sort of cool thing where basically you can sort of get the enum names defined independently. Yeah, it ends up generating something that's like this. I don't know, or something. But there was a GDC conference that might have done it in a slightly different way than this, where basically you generate all that information automatically so that you don't have to do this. So if I find that, I'll post in the Discord so you can take a look, because that's pretty nice for that. Okay, then you got some basic checker functions, is function, is white space. Okay, I think there's also one more thing in here too, possibly. I don't know. I think slash V is for vertical. Like you can actually embed different things, but I'm not completely sure on that. So yeah, there's a lot of weird escape codes and stuff. Okay, is alpha, so that just checks to see if it's character. And then you have L bound. Oh, so this just checks to see if it's, okay. Checks to see if you have a null pointer or something, I think. Maybe. L match. Okay, so this is where I'm starting to see the similarities to like crafting interpreters, his Lexer and stuff. That's end of file. Oh, that makes sense. Okay. So then you got match, which basically just checks to see if you get the expected character and returns true if you do, and then increments it. Okay. And then you have make token, error token, double handle, triple handle. Okay, so what's double handle and triple handle? So this is yes, no. Oh, so this is, okay, I see. This is just for checking like 2 things, checking 3 things. Gotcha. And then advancing is just doing that. That's undefined behavior. L, technically, I'm guessing, is that undefined behavior? I don't know. If you do a -1 in a, does that go backwards? -1 in pointer dereference. How I'm interested in this. I've never seen that before, but that's pretty cool. Pointer array subscript. Yeah, it does go backwards. So it does. I'm wondering if that's like actual behavior, because that's, let's see. I don't know. I'll have to look that up later. That's interesting. I've never even thought of trying that, but that's really cool. And I'm guessing you're doing bounds checking here. Okay, I might add bounds checking just to make sure that current is greater than 0 so that you don't go into undefined memory there. But yeah, that's cool. And then peak just returns current. Peak next. Okay, yep. So then you just do this stuff. Oh, and then you check to see if you're at the end of the file to make sure you don't go past it. So that's good. And then you have this skip white space. Oh, cool. So we could add comments in really easy, right? If you just add comments as like white space. So if you just did something like case slash, I guess we have to do 2 slashes, or this is a /. If you do like / followed by / and then you just keep advancing until you get to the end, because this is a while true anyways. Yeah. So if you match 2 slashes or whatever, you could just keep going there. But that's cool. So we just skip over white space is what you're doing there. Then string. So this just matches on a string. Char. Okay, so you're just doing some basic stuff. Okay, so you only have 1 character literals right now too. Character literals can get really annoying too. It can't go below 0 because I'm incrementing first. Okay, cool. So you don't even have to worry about that. And try using cpp.sh for quick running code. Oh, cool. So you can just... Where's cpp.sh? Is that like something that you have in here? Or is that something... Is that something that you're just saying like I can do to sort of like quick evaluate? It's a website. Okay, yeah, that's what I... So yeah. Okay, I might do that later. But yeah, so then you got number. This basically just checks for floating point. Floating point numbers are always a pain. And it looks like you don't do exponents yet. It'd be cool if you support that too, because I think, does C support exponents? Can you do 3E10? Yeah, so that'd be cool too if you had support for that, which looks like you should be able to inject right there pretty easily. And then you just have matches. Okay, so then you have the identifiers. So this is return, while, bool, char, long. So all the different types of things. Structure. Oh, cool. And then you have special stuff for structures so that you can do... Oh, this is just because S could be multiple different things. Okay, that makes sense. Do you have any special keywords in here? You have native. Yep, so native is a special keyword. You have null pointer. Cool, so you added that. And you added null. That's cool. I is int and if. That makes sense. Double for float else. Okay, cool. So it looks like you have a couple of false. It looks like you have a couple of special identifiers in there. It's always interesting to add new identifiers and stuff and what would make sense. And then this is where it does everything. Yeah. So you basically just match here. So this is probably, yeah, if you would do your extra slash in here. Oh, you do have comments. Yeah, you got comments enabled. So we should be able to parse through those pretty fine, and then you just skip over that stuff. Oh, you just don't have multi-line comments done yet. Okay. Cool. And then you have support for hex and oct numbers too. That's pretty cool too. So that's like one of the main files, and I'm guessing this is your memory manager. Okay, yep. So you just got a bunch of different things here. This is your memory arenas and stuff. That's pretty cool too. And then the parser. So what are you doing for parsing? Are you doing like a recursive descent parser, or are you doing something different? Do you have like an entrance function for this that I might be missing? It's probably gonna be at the bottom. So that's print AST. Okay, print AST indent. Free initialize. Okay, so this is the initialization. So then you have hash tables and everything, and then parse. So we go advanced parser, and then you go p declaration. So that's your first guy. Okay, and this returns a statement. Cool. So it looks like you're doing recursive descent, and then you check to see. Oh, so you're also lexing on the fly is what this looks like. So you're basically doing recursive descent parser and then lexing as you parse it, which is pretty cool. So if you're doing lexing as you're parsing too, you might be able to switch to streaming the file instead of just reading it all at once, and then like sort of streaming it in to like just a dedicated buffer. It complicates things a little bit more, but then once you start parsing multiple files, that way you'll only ever use a fixed amount of memory when you're doing that stuff, which is cool. It's a pain though. Okay, so you basically just check everything here, and then you say if you match native. Okay, so then you're just sort of marking different things here. And then, yep. So yeah, and then you go into either a function declaration, a statement variable declaration, or statement structure declaration. So basically what this looks like it's doing is it's like declaration basically goes to native or statement function decal or statement var decal or statement structure. So this is sort of your top level thing, I guess, and then statement enumeration decal. And then statement. Cool. So yeah, so this is all pretty basic recursive descent parsing stuff. Yeah, function var structures, enums, regular. Yeah, that's pretty cool. So we basically go through. Oh, you do pre-parsing too. That's cool. So do you do? Let me check your other examples. Hello world. Okay, that's that. Structures. Is that? I'm guessing the pre-parsing might be something else. Enumerations. Yeah, so I'm guessing that pre-parsing is probably doing something different than what I'm thinking. It's not like macro parsing or anything. So, oh, this is pre-statement. Yeah, so, okay, yeah. So this is for like parsing through variadic arguments and stuff is what it looks like. And then name mangling. Cool, so you do the name mangling too. That is something that I would be interested to see. So we've got this. Do you have any examples in here with the name mangling? I don't know if you do. Let's see. Nope. 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 But if I did do that, so if I went into here, so this is main. So if I had like a void foo int x, I'm guessing this should work. And I'll implement those just so that they have something. And then this is structures.cpp or CP. So it did it successfully. And then if I look at generated, we've got, yeah, foo1 int, foo1 float. Cool. That's pretty cool. You'd think that works. Yep. Pre-parser is for late binding functions and stuff. Okay, cool. Yeah, this is turning into like some pretty legit code. Okay, so then the parser, I'm guessing this just does the rest of the regular parser stuff. where basically you go through, this is interesting. So this is for printing the abstracts and texture and everything. But yeah, so I'm guessing this just goes through and follows the rest of your grammar rules and stuff. Oh, and then you implemented that Pratt parser thing that he talks about. I still don't understand how this thing completely works. It's really cool, but I have no idea how it actually works. So I'll have to look into that more to figure out what it's doing, if there's anything special there. But yeah, and then I'm guessing you also have this emitter, which just emits C code. Yeah, so if we look through this, it's just writing like if, and then you get the proper stuff. And so this just walks your syntax tree is what I'm guessing this is doing and stuff. Emitting code as it goes. Yeah, this is pretty cool though. What data structure? You got a hash table and stuff in here. Ooh. That is also fun. Hash tables and stuff. I hate hash tables. They're always such a pain to get working right. So, but it looks like you've got some pretty legit stuff in here. Okay, cool. If you can see at the top, it adds the declarations of generated.c. Does it? At the top of generated.c. There we go. Oh yeah, so it does, oh, right here. Yep. So it adds all of those declarations and stuff. So this is, I'm guessing, the late binding and stuff that you were talking about. This is pretty cool though. I like how it's turning out, and I'll be interested to keep following it as you keep adding more stuff and everything. So you'll have to keep us updated, because if you get CP working, I would be interested in trying to use it. We can try and compile my project with it at some point, and if that works, then you've made it. So thanks, Voxel, for making me feel like a hobby programmer. No, this is pretty cool though. This is turning into some legit stuff, and you're organizing it all pretty well. Simple build process. I love that. Just a couple things and it's all good. So that would be awesome. I agree. But I like how it's turning out, Voxelverse. Thanks everyone else who was able to make it to the stream as well. I hope you guys were able to enjoy it. And your project uses so much C++ though. Yeah, I know. That's why it's the true test. If we can get through that, then this is like golden. So, but yeah, thank you everyone for coming to the stream and everything. We've got some simple trees working. We've got the basics of Minecraft working. It's turning into a legit game. So I'll probably add some more stuff later today. There's not going to be a stream tomorrow. I might do one Saturday, but I'm not sure about that too. I will continue working, but next stream might be just next Saturday, and then we'll continue from the old schedule from there. So yeah, thank you everyone for coming though, and I hope you enjoyed it, and I'll see you next time. All right, see you guys.